something like chromium, molybdenum, right, and also copper and silver. So right off the bat, I've already mentioned this, but I'm going to say it again. There is the concept that these guys, this one and this group right here, you would think it would be 4s2 and 1, 2, 3, 3d4. But we're going to find out that this does not happen. So like this, I'm going to put a line through. That is not going to happen. Just like with copper here, you would think it'd be 4s2 and, I'm sorry, this would be 4s2 and it would be 3d9. But that's not going to happen either. So we think it's 4s2 and 3d9. But what we're going to find out is that 9 and 4s kind of don't really show up in this chart. And I'm going to show you what happens as I do the box loading diagram, what really does occur. Okay, so I'm going to close it. I'm going to go back to this guy. All right. And the reason why I'm doing this is so I can load them. So I'm going to grab the first guy, right? Who we're not going to go into these, so I don't really care about it. I'm going to reduce my pen size so I can see what's going on. So I'm going to put my first guy here. So we are looking at, say, chromium. So we know it's, according to this periodic table, 1, 2, 1, 2. This is 2p, 3s, 3p, 4s, and we're going to go up to, it says 3d4. So I'm going to load all these guys in real quick so you can see where we are. So this is up, down, and then we go up, 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 then down, down, down. And we're going to go up, then down, up, 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 then down, down, down. Now, keep in mind, look, we're on a periodic table. Now we're into 4. This is 1, 2, 3, 4, 4s1, 4s2. So let's load these two guys in. 4s1, 4s2, right? Now, even though it says 4p, we're not going there now because this is the 3D. This row right here. So it's going to be 1, 2, 3, 4. So now we have, right, 3D, 1, 2, 3, 4. All right. Now, this is not comfortable for an atom. They don't like this. They could, oh my God, think about this. You're putting one electron in each orbital, except we have one that's empty and we got 2 here. Now, without trying to get too complex about what the inside of this thing looks like, right, that these guys all have 1 here. You want to maximize your upward spin. This is one of Hund's rules. So what you're going to do is you're going to steal from 4s and stick him up here on 3D, like that. So now look, we got 1, 2, 3, 4, 5, 6 going up, right? Think about that. When before we only had 4 going up. So this works better for the actual atom. So the electron configuration for this, and I'm going to write this out longhand. We go at 1s2, 2s2, 2p6, 3s2, 3p6. Now, there's a couple ways you can do this. One is you're supposed to put the 3's next because that's in order. But you could also just write it 4s1, then 3, then go 3d5. Okay? Or you can write it, it's most, I do it this way because it's the way we're loading it, but it's mostly known as this. So you might get it in multiple choice question format with the D's coming for the S's. That's how most people note it, but if it's easier on your mind to write it the way you're loading it, I'm fine with that, okay? There's an actual easier way to actually write this whole thing. You go from the last noble gas, and then you mark from there. So if we look at the way we're doing this, my last noble gas before chromium, in this case, would be argon, right? So if I look at the way this is written, I could easily have written this thing this way, chromium, and we put argon in a bracket. If I have a noble gas configuration argon, right, which takes me up to 3p, right, then I go 4s1, 3d5. That's the shorthand notation most people use. I'm showing you where that came from, how you get to where we are with this. Let's take a look at copper now, right? Copper is going to look about the same. Probably shouldn't erase everything, but arrow up, arrow down, arrow up, arrow down, arrow up, 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 down, 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 arrow up, arrow down, arrow up, 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 down, down, down. And then we're going to go for S1, for S2, 3D1, 2, 3, 4. What's the rule? Oh, that feels uncomfortable. I'm going to take this out. Okay. Then I'm going to put this one here. Then my next one I load would be this one. Okay. What is this guy on the periodic table? What's the next one? It's manganese. That's what he would look like. Okay. Just kind of letting you know what's going on. So then we start loading this guy. 1, 2, 3, 4. And I said you can't have 9. That's uncomfortable. This is copper. It's got a 9. So what it's going to do, once again, the old switcheroo, it's going to steal this guy and put him here. Okay? So in doing so, this guy becomes 4s1. So to write that out, once again, it's 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. Okay? If you did shorthand, it'd be, as it was before, ergon, and then you start counting. It'd be 3d10, 4s1, right? So the next thing I'm going to show you a little bit is it's going to do the same thing with silver or any of those guys. It's always going to want to have a 10, 5. It's not going to want a 4. If you were to make copper as an ion, if it says copper plus 1, you always pull from the highest quantum number, which would be 4. So copper plus 1 would be CuAr 3d10. That's copper plus 1. That's what it looked like. Okay? It's a little strange, right? So I'm going to show you other ones that look like ions. Okay, let's clear this. Let's take one of our, like oxygen. Oxygen, it's a little simpler than you can imagine. So oxygen, right, we know is 1 up, 1 down, 1 up, 1 down, up, 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 down. But oxygen will make a -2 ion, and guess what it looks like? Like that, and it has what? Noble gas configuration that looks like neon. So actually neon and oxygen -2, or fluorine -1, or sodium +1, all look the same as far as their electrons, if you think about it. So we call these things isoelectric series. So the electron configuration is the same, right? If you have one, and like I just did this one with copper, let's clear this, right? And if you did this one again, let's say we do this 1 up, 1 down, right? 1 up, 1 down, 1 up, 1 up, 1 up, 1 down, 1 down, 1 down. Then you have 1 up, 1 down, 1 up, 1 up, 1 up, 1 down, 1 down, 1 down, right? Then we did this. We had this thing is 1 up, 1 down. We loaded this thing 1 up, 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 up. Steel, it's got to go away, right? He goes up, right? And then we load this guy up, and then we have this one, this one, this one, this one. And obviously, oh, we can't have that, right? That's illegal. It doesn't, sorry, that doesn't feel comfortable for the atom. So we're going to take him out. We'll put this guy here. And then what do we do? Then we load this guy, right? And we keep on going. But let's say this is copper, right? Right here. This is Cu. That's what it looks like. Copper 1, as far as copper losing an electron, right? It takes away this one. It's going to have a noble gas configuration, but we can't really call it that. We look at it, it sort of looks like argon, right? Except for one thing. What? It's got these d electrons. So it's 3d10. So we call this a pseudo noble gas configuration. And I'm spelling configuration wrong, but figuration. Is this thing in the way? I can't write. Here we go. Okay. Figuration. So it sort of looks like argon, except it's got the D's filled, right? So that's kind of the way it looks that way, right? Try to think of anything more pensive about this whole electron loading there is to really know. Um, this pretty much takes you through all these guys here on how to load them. Selenium, zinc, chromium, molybdenum. Now we have these guys, and once again, you look at it and make a distinction based on um, where this is and where would you always lose the highest quantum numbers first. To kind of illustrate this, I have, for your viewing pleasure, uh, there's a little passage here that explains ion configurations. What that means is when you lose an electron, what's it look like? Okay, that's like one page. That's not a lot of reading. That's enough to get the idea. If you are confused about it, there's 2 short videos this guy did. Or I like the guy who sounds like Sheldon. He explains how do you get iron plus 2 or iron plus 3. He walks through the entire thing. Very nicely played. Mike North. And here's copper ions. Explaining all right, guys. Lots of people ask the configuration to copper plus 2. Both of them are kind of go into. He does a nice job explaining what's going on there. I'll do one more. I do vanadium plus 2. So I look at my periodic table. I see vanadium is right here. Okay. So we can look. All right. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 1, 2, 3. Right. So let's take a look. How would this thing look? Where's it? Here. All right. So I'm going to start loading my arrows. 1, 2, 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3. So when you lose electrons, you lose from the highest quantum number first. So vanadium, like this, would be that. If I was to write this out, okay, it'd be vanadium plus 2 equals 1s2, 2s2, 2p6, 3s2, 3p6, right? 3d3. You can have a 3, you can have a 4. Or you can say vanadium plus 2 equals, this takes us all the way up to what gas? All the way over here. Sorry. All the way up to ergon, once again. So I'm going to say, I'm going to call argon. Argon 3d3. That's what it would look like. So at this point, it's just more or less practicing to see what you're going to end up with. Okay? And it kind of makes sense. Looking at the rest of these guys, zinc ion, oxygen ion, nitrogen ion, they're all super doable, right? There's several different designations here. The arrow means noble gas configuration. Right? And we do the box, you want to do a box diagram on 1s2, 2s2. So you know every way to do this thing. The other one's a long one, that's when you're writing the whole thing out like I just did, right? So if I was write the box diagram thing for copper, right, based on what we know, it is 1s2, 2s2, 2p6, 3s2, 3p6, right? And then it's what? 3d10, 4s1. That's one of the ones we just did, right? So kind of shows you how you would do this, okay? Because at this point, it's just practicing and it makes sense to you, right? That's it.